CSI Flight Adventures is produced in partnership with the Children's Museum of Indianapolis, WFYI Public Media, and the Academy of Model Aeronautics. This collaboration is made possible through a grant from the National Aeronautic and Space Administration.
In this fourth experience, we're going to make a pretty amazing model. We've talked about the two forces of lift and weight, and we've also talked about the two opposing forces of thrust and drag. Now, in order for an aircraft or a model to fly, we have to be able to control those forces. And in this experience, we're going to make a model that follows in the footsteps of the Wright brothers and learn how to control an aircraft. It's called the FPG-9, which is a pretty cool name for the foam plate glider 9-inch. There was a plan similar to this that the AMA used for many years, where students were asked to bring in a styrofoam egg carton. The limitation of that was that there are not a lot of styrofoam egg cartons out there. And one night, one of their members by the name of Jack Reynolds thought, well, let me think about this. He went home and with his grandchild got a foam plate, came back the next day and said, hey guys, how about this? Will this work? And that was the birth of the FPG-9 foam plate glider. This is an excellent model, a science apparatus to learn about flight dynamics of lift and weight, thrust and drag, and more importantly, control, because it has control surfaces, just like an airplane that flies now. It has parts of the plane that can move and interact with the air going over them and cause a small change in a control surface will make a large change in the flight profile. So let's get started. This is one of our mainstays of this unit of study because this pulls together all the things we've been learning so far in the three previous experiences. Okay. In the lesson, you'll find a student handout, and this is actually a template, a new vocabulary word, template. And I'm going to cut one of these out of paper. But I'll tell you, if you have some older students or maybe some parent helpers, a very successful technique is to have someone come in and cut out templates out of styrofoam plates. And that way your students will have kind of a heads up on how to move this project along a little bit better. So here's 15 templates that I've cut out to use with a class of 30 where they share the templates. And so I'm going to take you through how to cut out the template, how to cut out the styrofoam template, and how to make the FPG-9. Let's get started. Okay, when you cut this out, it's important for the students to remember that they follow the dark lines. And if you're a third grade class, I've done this with third graders all the way up to sixth graders, and they seem pretty successful at doing this. Take your time. Once they make this template, they'll be able to take it home and make more of these because, as I said earlier, I don't expect them to be experts the first time they make this, but I do expect them to revise it, make it better, and become aviators as they improve their models. So I'm going to go ahead and cut this out. These wings are a little bit longer because they fit in the fold and the curve of the foam plate. I'm going to cut out the tail of this. And you'll notice there's some slots. Now I made the slots a little bit larger than they have to be on the template to take into account when the kids actually trace these. And so here's that center slot on the wing. I've cut it out. Okay. There are some vocabulary words. You'll notice that on the template we have several words that I expect the students to know. So we have this now. This may be kind of difficult. They may not see how this becomes this. On all of these models, I think it's important that you make one first to be able to hold up and show as your students make them. But most of your students will notice that this part ends up being the tail, and this is the delta wing. In the unit of study, this is actually attached to a couple really cool NASA projects, one being the F-15 Eagle. All right, so this is one way to do this, and then it should fit on top of this plate. But before I do that, I still need to cut out another slot here on the tail. And it's about the same size as the slot on the wing. Like I said, if you have time, have someone help you cut these out ahead of time, or make them out of foam. Either way, this is a successful project. I've cut that part out, and I like to just bend it up and pull. When I show this to the students, I pull that little part out right there, and we have the two slots. Okay, I'm going to lay this on my plate, and if you work in teams, that's a good idea where you can have two students working at a time. One can help hold. Probably the most critical thing is that the tail back here is flat on the flat part of the plate, not on the curve. And I'm going to use a ballpoint pen, and I'm going to start to trace this. And I got a little notch here, and not only am I tracing it, but I'm scoring it at the same time. And so I'm tracing around the different slots. And I always like to stress to your students to try to make this balanced and symmetrical, because if it's going to fly through the air, you want it to be balanced. Let's say something happens and they move this and it gets moved like that. Just simply put it back on there and have them realign it so they can continue tracing it. There's a couple lines right here that they can push down and score, and right here. And now we have the top part to do. I think I'll just turn this around so you can see it better. And I'm going to go ahead and follow my pattern. And I end up making something that looks like this. I can draw this across the side here. And now it's time to cut this out. And when I cut it out, there's two ways to do it. I'm going to go ahead and cut it all the way out just like the pattern says. It's easier to move the plate than it is to move the scissors because this foam is kind of rigid, so I cut that way and just cut off a piece like that. Try to tell your students just to take their time. There's no big rush on that. So I'm going to cut there. I'll move this over and cut here like this. And I've got my tail on there. I'm going to go ahead and round this a little bit here. I'm not cutting any of the slots yet. I'm just getting the rough cut out. And you notice I turn the plate instead of turning my scissors. It just makes it easier to cut through these. Okay, this has been roughed out, but there still is two important slots to cut. Now I'm going to cut down this slot right here, and I'm not going to make it too big. I only want it about as thick as the actual foam plate. And so it's not too thick right there, and I can just stick it up and pull that out. If you make it too big, it'll wobble when you put these together. Now, if you lay this back on here, you notice that there is a dotted line right here, and that's where the tail goes. And so there's two ways to do this. You can lay that on there and score it like this. And when the students pick this up, you can kind of see the line, or you can just kind of continue that line right here. If I was going to use this as the model, I'd go ahead and cut this off. If I was going to use this as a template, I wouldn't cut it off. And so I'm going to go ahead and cut this one off just to show you. And now I have my two parts here. And I need to cut the slot now in the tail. And once again, don't make it very big. We just want it to be able to fit into these two slots right here. So this will eventually end up doing something like this. Fitting into there perfectly like that. Fitting in just like that. But if you remember, there was a couple lines right here for something called the elevon. And I have the students say that word, elevon. A lot of the words on an airplane come from the French language because the French were very important in the early history of aviation. And so many airplane parts, fuselage, elevon, aileron, are all words that have origins in the French language. Now I've marked where these are. And so what I like to do is go ahead and make the mark here and make the mark here. And I like to write the letter E for elevon right there on there. So I'm going to go ahead and put an E on here. There's my elevons, and there's two of them. And I'm going to take my scissors, and I'm going to go ahead and cut this, just one small cut. And over here, this elevon. And I'm not going to bend these yet. Don't bend them yet, just have your students cut them. They're ready to go. And on the back of the tail, if you notice here, there is also two different marks that we need to make on here. I'm going to lay this back on it and mark these, and that's where my rudder goes. And so I'll mark it here, and I like to write an R for rudder. And now what we have done here is we've created three different control surfaces. We have a rudder that can be bent right and left. We have two elevons that can be bent up or down, and these become our control surfaces. Okay, before I put this together, I'm going to show you how you can also make this by just using a template. And so I have a template that I've already cut out, and the template is a lot easier, I think, than using the paper. So I just lay it on here like this and mark it, and there's my elevons. I've cut out my elevons on this template. Here's my slot. Here's my tail. Here's my slot. Now, to make this easier, I went ahead and cut out where the rudder goes and the elevon right here. And then finish up the front. Important thing to remember to tell your students is that the tail goes on the flat part of the plate. And you see that using the template, it's a lot quicker, and you can save these over and over again. I will tell you this, I numbered mine because every time I use this with a set of class, I usually end up losing one, and I usually end up getting the tail cut off of some of these, but that's part of working with kids. Okay, so here is another one of our templates that we could cut out. Instead, I'm going to go back to this one right here. All right, so we have our delta wing and we have our tail. Now it's time to put these two together, and they simply slide together like this. Now, I didn't cut them too large, so they should have a nice, snug fit. And if you look at this, it should be a nice perpendicular, another vocabulary word, with right angles, here, opposing right angles on this. So I've got that in there. Now it's time to take some tape, and I'm going to turn this over. I'm going to put a piece of tape here to hold this vertical tail, or another name for that is vertical stabilizer, in place. And just to make sure, I'm going to put two small pieces over here. Now I've noticed that sometimes students, when they put the tape, they end up having a little gap there, so it's important to kind of push that down. So that piece of tape's there. And this piece is here, and we have a nice tail ready to go. Now I found one other thing that you may think that's odd, but I like to take my pencil and draw an arrow and have the students draw an arrow in the direction that this FPG-9 will fly. That may sound simple, but there's always one or two kids that get embarrassed when they fly it the wrong way. So if you want to get fancy and let them know something that you know about this plane, this is called the leading edge, and this is called the trailing edge as this flies through the air. All right, if we flew this right now, it wouldn't do much because it doesn't have much weight, and we wouldn't be able to throw it. A good example is if I took a paper ball and threw it, I could throw it maybe across the room, but not much further than that. If I added more weight to it, if I used a paper ball and a baseball, same size, I could throw that baseball a lot farther. So we're going to add weight to this so we can make it fly farther. And the way we're going to do that is with a good old U.S. penny. U.S. penny, it looks like Abraham Lincoln's going to be our pilot today. So I took a piece of tape, I lay the penny down, and I'm going to lift this up, and I've got Lincoln right there. And that way it's going to be a lot easier to move when I put it on the FPG-9. So it's important to stress to your students that we're going to try to keep these aircraft balanced. So try to get that right in the middle of where they think the plane is balanced. All right. Without that penny, this will not glide very well at all. Now it's time to put the seatbelt on, and so we're just going to bend this tab back here like that, and take a piece of tape and secure President Abraham Lincoln with a piece of tape, and he's ready to go. And that's how you build the FPG-9, foam plate glider, 9-inch. Now it's time to use this model to make some test flights to see if we can control how it flies. Now that you've constructed the FPG-9, it's time to learn how this model can demonstrate some of the principles of controlled flight. These are the same principles that the Wright brothers struggled with and overcame over 100 years ago at Kill Devil Hills. One of the first things that they noticed that a plane can do is roll. This is one of the 3 ways a plane can move. This is called roll. And they did it by wing warping. Another way that a plane can move is called pitch, up and down, pitch. So we have roll and we have pitch up and pitch down. And the final way a plane can move is called yaw. Yaw is turning this way and this way. So we have 3 different ways that a plane can move and 3 different ways that a plane needs to be controlled. Roll, pitch, and yaw. And this model can show all 3 of these as your students use this model to do their research flight cards and take it through its flights. All right, so the first thing you want to do is make sure that it flies in a nice glide path that's straight. To fly this, I'm going to tell you right now, most of your students are going to do 2 things that are going to cause problems. They're going to throw them too hard, and they're going to make big bends and changes on the elevons or the rudder. Those are 2 things that you want to try to stress that they don't do at first. Your first flight, elbow up, and it's a glide. Just like the space shuttle that glides back to Earth, this is going to glide. I'm going to see on my first flight if this does go in a straight, nice glide. Once again, use the same techniques with the rockets, although this one doesn't have any sharp edges to cause you trouble with. So 3, 2, 1, launch. Clear. Now I noticed on that first flight that my plane did a little bit yaw to the right. And so I'm going to give just a little bit opposite rudder to the left. Now I'm giving these directions, and you can tell your students that I'm looking at the back of the plane. So when I say right rudder, the orientation is from the back of the plane. In fact, on the student worksheets, that's how I've drawn their flight cards from the back. I'm going to turn that back around now. So since my plane was going this way, I'm going to give it a little bit of left rudder to see if I can get it to go straight right at the camera. Here we go. That one went a little bit straight. Clear. Now I notice it still did a little bit yaw to the right, so I'm going to give it a little more, just a little bit more left rudder, and see if I can get this to go straight at the camera. This is called trimming your aircraft. 3, 2, 1, launch. And I still have some left to it. Now, that could be because I don't have the penny exactly right, but there's things we can do to overcome that. Clear. All right, so as your students go through this, I got a little bit of left rudder, and since it's going that way, I'm going to put a little bit of down elevon. Once again, down left elevon, because it's on the left side of the plane when you look at it from the end of the plane. Here we go. This one maybe will go straight. Let's see. 3, 2, 1, launch. And I still got a little bit of yaw to the right. Clear. Okay, so you can take your students either in your classroom, in the hallway, cafeteria, or if you're lucky enough to have a gym, that's a perfect place to do this. And once again, you can have them alternate or all be on one side. Now, I'm going to take you through a few different exercises so you'll know how to do this. I think it's important that you try this out first before you do it with your students. And one of the first things I want to do is I want to do down elevons. Both of these down elevons. Now, if I put both elevons down, when I throw this, I predict that it's going to go down. In fact, I'm going to throw it kind of hard, and we should see what you call a crash, no burn. Ready? Both elevons down, and it should go straight down. 3, 2, 1, launch. And it went straight down. Clear. Okay, so down elevons caused the glider to go down. What do you expect is going to happen when I put both elevons up elevons? Let's find out. Both elevons are up. I'm going to throw it hard. If it does the way I want it to fly, it should pitch up. Last one pitch down. This should pitch up. 3, 2, 1, launch. Cool. You see it pitch up? Very nice. Clear. So this model is designed to let your students investigate control. What would happen if we do one elevon up and one elevon down? What would happen if you do sharp right rudder? We're all trying to work on either pitch, roll, or yaw. The 3 ways a plane can fly. I think I'm going to see about hard right rudder and maybe up, down, one elevon up, one elevon down. Who knows? Let's see what this does. 3, 2, 1, launch. Nice roll, nice pitch, clear. The FPG-9 is a pretty awesome model because it teaches us a lot about how we control an aircraft in flight. 2 things to remember is that small changes in these control surfaces, the elevons and the rudder, make big changes in how it flies. And also, how hard you fly it will also be a variable that your students need to consider. So have your students make these and have them put them through their test and record their flight profile. And what you'll end up learning is that NASA also has done some of the very same things that they're doing with their FPG-9. Once you make these 4 different models, it's time for your students to do the culminating activity and assessment. And that's where they will take everything they learned about opposing forces of lift and weight, thrust and drag, and how to control an airplane in flight with pitch, roll, and yaw. And they will design, build, test, and fly their own creation, putting all this together. And that's the point of this. We may not all be pilots on a NASA project, but with this unit of study, all of your students can be aviators.